So last video we see how to evaluate the integrals, that is integral over 0 to 2 pi f of cos theta comma sin theta. In this video we are going to evaluate the integral that is whole real line. Okay, that is the type 2. So that is minus infinity to plus infinite f of x dx. Here f of x equal to g of x over h of x. Here g of x and h of x are polynomial in x, and degree of h of x is exceeds that g of x by at least 2, and no poles of f of x lies on real axis. These are the assumptions we made. Then we are going to solve this type of integral. How to evaluate, that is we are going to see now. Okay, now we choose the circle. Now we choose the circle C, sorry, not circle, we choose the curve C. Curve C consisting of the interval minus r to plus r on the real axis and the semicircle mod z equal to r lying in the upper of plane plane. Here R is chosen sufficiently very large. So that all the poles lying in the upper half of the plane. Or interior of C. Then we have integral over this. So first I want to, so what is the idea? I will draw the graph first, okay, then I will explain. I take the, so this is the complex plane. Now I will choose, I draw the curve, so this is now looks like so. Okay, this is my curve, and okay, this is the my curve C, and this is the interval minus r to plus r. This is minus r, this is r, plus r. So this is the positive oriented. I take C1, this is curve is C2, that's the C1 plus C2. This is my curve C. It's a simple closed curve, correct? So now I can use the Cauchy residue theorem. That is my aim. I want to convert. So that meaning is, so that means integral over C f of z dz is equal to integral over C1 f of z dz plus integral over C2 times f of z dz. I can write, correct? Now you look this integrand only first. Okay, so C2 is here only the real integrand. What is the y value? Y is always 0 and z value, x value lies between minus r to plus r. So I can rewrite the second integrand as directly integral. So this is integral over C1 f of z dz plus integral over minus r to plus r f of z is x because y value is 0 times dz is I can take as dx. So now this is my integral over contour integral of f of z dz. Suppose r is going to infinite, okay, this integrand is going to 0 using Cauchy inequality. So thus this integral whenever r is going to as r approach to infinite. So this meaning is integral over C f of z dz equal to minus infinity to plus infinite f of x dx. So this is my a. Okay, whenever C is going, r is going to infinite, this guy is going to whole upper of plane as r tends to infinite, correct? So using, so that is my idea. So that meaning is the real integrand we are converting to the contour integral. Once we are in the contour integral, I can use the Cauchy residue theorem. So now we see first example. Evaluate the integral minus infinity to plus infinite dx divided by 1 plus x power 4. So this function is very difficult to integrate, first of all, because the antiderivative is very difficult. Okay, so now I am going to use the Cauchy integral formula only. So I clearly, there is no pole, that is, suppose I take and I say f of x equal to 1 over 1 plus x power 4. So then this implies I take x equal to ez equal to 1 over 1 plus ez power 4. So thus no pole lies on real axis. Okay, so the denominator power is also higher than, at least higher than 2, because the degree of h of x is g of x is 0, here is degree is 4, it's greater than 4, okay. So 4 is difference will be there. So at least 2 means we can proceed. So degree is more than 4, so we can apply. So now I want to find the what is the singular point. So singular point of f of z is that is z power 4 plus 1 equal to 0. Then this implies z is equal to exponential of I pi divided by 4. So you already know that how to find this in your school class in 12th standard, correct? So it's the same idea I am applying. Exponential of 5 by 4 and exponential of I 7 pi divided by 4. So okay, now my aim is I want to find what are the singularest point in the upper of plane only I want to consider. The lower of plane I don't bother. So then what are the two? So these 2 points are only in the upper of plane. Please plot it. So it's cos pi by 4 plus I sin pi by 4. It will be automatically in the theta value is always in the first quadrant only will come, this one, correct? This one will come in the second quadrant. These two come third and fourth quadrant. So this implies, so our integral over C f of z dz equal to 2 pi I times summation of j is equal to 1 to 2, because here 2 only, residue of f of z at zj. So zj is, one is exponential of I pi by 4, second one is exponential of I 3 pi by 4. So first I want to find residue of f of z at exponential of I pi divided by 4. So simply you apply, you will get the answer is, because it's a simple pole only, you can use the first or second formula, you directly get the answer, or you can use the third formula is here. I think it's very useful here. So you apply the third formula. If you want to how to evaluate the residues, I already posted a video in our channel, please visit, or I will give the video link in the description of this video, okay, how to evaluate. Similarly, residue of f of z at exponential of I 3 pi divided by 4 is exponential of minus I 9 pi by 4. So integral over f of z is two pi I times summation of residues. So I forgetly missed divided by 4 here and here, okay. So divided by 4, exponential of minus I 3 pi divided by 4 plus exponential of minus I 9 pi by 4. So if you find this value, you will get the value is pi over square root of 2. So this is contour integral of f of z dz. So from our assumption, so it will automatically it's equal to minus infinity to plus infinite f of x dx, that is pi over square root of 2. So in this integral easily we can evaluate, but it's, you look, these improper integrals are very difficult to evaluate. I hope you understand how to evaluate the improper integral using contour integral. Thank you for watching this video.